So today we are looking at the nth term of linear sequences. They could be quadratic sequences, which will be on a separate video. So let's have a sequence. Let's have 7, 10, 13 and 16. Now nth term is about writing an expression, okay, it's a bit of algebra without an equal sign, to determine the sequence of events here, okay, the sequence of the numbers. Now, the first thing we do, whenever we see a sequence, we've kind of been drilled into us, and we need to find the term-to-term rule. And here we are adding on 3, okay, and we're adding on 3 here. So this means we're going to use 3n, okay? I'll explain a bit more what the n means in a minute, just bear with me. So that's the first step. Second step is looking at the relationship to get from the 3, or the coefficient of the n, to get to the 7. And to get from 3 to 7, we add 4. Which means we put add 4 on the end. Right, so this n represents which number of the sequence we are looking at. So the 7 would be when n equals 1, because that was our first term. The 10 is our second term, therefore this is when n is 2. This is when n is 3, this is when n is 4. So looking at a bit of substitution then, if n is 1, then this means 3 times 1 is 3, plus 4 is 7. So then when n is 2, 3 times 2 is 6, add 4 is 10. 3 times 3 would be 9, plus 4 is 13. When n is 4, 3 times 4 is 12, plus 4 is 16. So this nth term expression is for this sequence here. Now we could work out the 5th term. Yes, you're right, we could just add on 3 to 16. We know the answer is 90. Let's use substitution. This time, when n is 5, or the 5th term, the substitution, 3 times 5 is 15, add 4 is 19, so we know. Now, if we wanted the 6th term, we just add 3 on. But let's change it up. Let's go a long way down the sequence. Let's look at the 50th term. So to get the 50th term, this time n would be 50. So then 3 times 50 is 150, add 4 is 154. So instead of just adding 3 all the way down to the 50th number, we could just use substitution. So here then we did 3 times 50 and then added on 4. We could work out the 100th term, that 100th number on the sequence, by substituting the n for 100 by having 3 times 100 add 4 to make 304. So to calculate the nth term, the difference between the terms, or our term-to-term rule, is the coefficient. It's the number in front of the n. Then the relationship to get from this coefficient to the first term is what goes after the n. So using that knowledge, let's look at this one here. Our term-to-term rule would be to add 5. Let's check to see if it works for the second one. It does. That tells us we have a linear sequence when the difference is the same each time. So that 5 goes in front of the n. You'll notice I've used different colour pens to show where these numbers are coming from and where they're going to. So this 5 goes in front here. I'm even going to label it for you. And that's our term-to-term rule. And then the next part is the relationship to get from this term-to-term rule to our first term. To get from the 5 to the 2, we subtract 3. And that's what goes after our n. So then this part is the relationship from coefficient to first term. You can see where it's coming from there. If I wanted to work out the 50th term, so our 50th number of the sequence, the 50th term, I would use substitution. The nth term is 5n take away 3. Substitution, if the n is 50, that means we have 5 times 50 take away 3. Well, 5 times 50 is 250. 250 take away the 3 would give me an answer of 247. So the 50th term down the sequence would be 247 using this part here as substitution. There is a video about substitution. If that bit seemed a bit hard for you, have a look at the video. I explain it in a lot more detail. So terms to rule in front of the n. Relationship from here to the first term. So it goes after the n. If you need to calculate a term of the sequence, then you use substitution. Have a go, and I hope that helps.